something and you receive something over normal, even RF, you have ways to correct for distortions in the signal. Like for example, if you have two radios, transmitters and receivers of this and that, the signal that goes through the wall versus the signal that goes through the glass versus the signal that goes through the air are going to have different changes in like amplitude and phase, and those need to be interpreted correctly for the data to be what it is, like the data that you send. So usually you have the image below, it just shows that you have different markers, like known points of known amplitude and phase, and you interpret on the other side what those are supposed to be and what they actually receive, and that's how you correct it. So these are done at a per symbol level right now, and for low frequency waves it's okay because you can sample same signal a lot of times because the wave exists over a long period of time. For us, the wave exists for a really short amount of time, like we are in a few terahertz, so the waves are really small. So doing this kind of thing requires like really specialized custom code on stuff like FPGAs. And the techniques that have been developed kind of sort of work, but they're not always robust. So yeah, so channel estimation is one thing, and then adaptive modulation is, for example, in our case, you have atmospheric effects like I mentioned. So they don't affect radio waves that much because radio waves are much longer, and the atmospheric effects, the pockets in which these effects kind of change the refractive index of the atmosphere are really small, and like the closer it is to the frequency of the transmission data, the more it's going to affect it. So it affects laser beams a lot more. So if you have, for example, a huge area, the phase of the wave that comes to the same plane is going to be different, and you need to adjust for those phases. So you either have to do that or add redundancy in the signal or have changes in modulation. So adaptive modulation is something that's done in, like I mentioned, Wi-Fi already. Like you have 64 QA, and then you can go down all the way to like at 2 bits per like just on and off key. So doing the same thing for lasers is just, the concepts are the same, just implementation is really hard. Yeah. So this was just basically a summary of all the challenges that we face, and yeah, all I could tell you guys about. I just want to show you guys what we have planned for the future. So, like I said, we all are space nerds, and we had the same idea that this Amazon and SpaceX have a constellation of satellites that have high-speed wireless links between them, and also have ground stations that connect to those satellites. So anybody on the ground can access any other part, like with using those satellites. So I think Elon Musk tried, but in the end he ended up with microwave links between the satellites, right? He did not use lasers.
It's not lasers.
Yeah, it's not lasers. So the problem with those is just lower bandwidth, and there's a limit of like how much data you can transmit over a certain frequency. Is it Shannon's theorem, or I don't know, one of the information guys' theorem. Like there's only a limited amount of data that you can transmit over a certain frequency. So we want to be the first people who send satellites up, create a constellation, and actually use lasers to transmit data between the satellites. And yeah, our goal is to augment and maybe in some cases replace the undersea fiber cables that are currently going through. So for example, if you want to have a connection between London and Tokyo, it's going to go from Europe to like somewhere in Africa, then all the way back to somewhere in the Middle East, then go around and go to Southeast Asia, and then go to Tokyo. It's a lot of hops of fiber optic cables, like the undersea cables. What we would want to do is have it such that it goes up, goes like to a few satellites, and then comes back down at Tokyo. So like a really fast connection like that. And since it's laser, and we know that, by the way, any technology that we use in our current product is the same as that you would find on like I don't know, fibers that go to your home. So any improvements in technology that happens there is directly coming. It can be incorporated into our thing. Okay. And yeah, this is just our timeline. We are now done with our first ground product. It goes to 3 kilometers. It took us 2 years to reach this stage. Pretty happy. Yeah. Yeah. I remember like when I just joined the company, we were trying to transmit data across like this kind of distance. We were like, please do it. Like, if we can do it across the table, we're gonna have a beer and stuff like that. But at this point, really happy that we are able to transmit over as much as 3 to 5 kilometers. And yeah, our goal is in the future to first start testing on drones and balloons. And hopefully, if everything works out, we send something to space, try by the end of this year. Sorry, next year. Yeah, that's it. Right? Yeah. So, yeah, that's my email. You guys can contact me if you guys are interested in any internship or other kinds of things, or if you just want to ask me questions about what is going on in the space industry. Yeah, that's it. So if you guys have questions and stuff, you can ask me. No. I will try to answer them as, and I guess Fran is them. So I handle vision, and before Fran came in, I handled a lot of the embedded stuff as well. But now Fran is the head of embedded in electronics and all that stuff, and I handle the vision and the software of the pointing and tracking. So if you guys have any questions for us, we can get an answer. Okay, yeah.
Where will you launch all the satellites from?
We have, I mean, you know the wait, how I'm not sure. Okay, so we have a lot of different people that we're talking to. In the US, in Europe, in Asia, yeah, that's everywhere. Yeah, we have a few people that we're talking to, and we are just trying to figure out what will be the best for us in terms of the orbit and timing of the launch.
What's the question really?
Yeah, what do you want to know exactly?
Well, no, just where in the world you would launch them from, like from Florida, or we launch them from New Zealand, or from Singapore?
No, not from Singapore.
There is no way to launch in Singapore.
Yeah, in Australia, I think some people are coming up with some companies. But
I mean, to give you an idea, like the company right now, it's mainly focusing around the area, so like it's like a species, but like we already have contacts in the US, specifically in Australia also. So it's whatever it's going to be that is going to be easy to launch it. We already have some agreements that are being performed that we cannot use. So
yeah.
You mentioned that the accuracy of pointing is one of the greatest challenges that you have.
Yeah.
And what's the mission requirement for